not exactly on P. So these are the hybrid orbitals that are formed. Of course, you have something like this, like this, like this, like this. All right? So that at the end of the day, you are going to have sp3, 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 and here will be what? sp3. So this one, they are unhybridized atomic orbital. Unhybridized atomic orbitals. When hybridization occurs, you are going to have hybrid orbitals. Now, these hybrid orbitals, they have a specific shape. For instance, those of sp3, you are going to see a loop very big like this, and then you see another small one on top like this. This is the shape of sp3 hybrid orbital, more like a balloon that is tied at one end. Is that understood? So that's basically everything you need to know about the sp3 hybrid orbital. Then there is also one other thing you need to know, the carbon-to-carbon bond length. We are going to look at that one. I'm going to just state the three of them so that you know the differences between them. The carbon-to-carbon single bond length. Now, you should also know that for sp3 hybridization, the hybrid orbitals are formed what? Are side on. So at the end of the day, you are going to form only head on. You are going to form only sigma bonds. So you are expected to form here 1, 2, 3, 4. You are expected to form 4 sigma bonds. Is that okay? So that's basically that for sp3. We say percentage S character, 25%, percentage P character, 75%, bond angle 109.5 degree. Shape is what? Tetrahedra. Now let us talk about sp2. We're still coming back to everything we said about sp3. So X, percentage S character, percentage P character. All right. And then you have bond angle, the shape, and so on and so forth. So let us look at the percentage S character. Now this is spp. Total hybrid orbitals is, total atomic orbital is 3. So how many X are there? 1. So 1 over 3 times 100%. So this will give us 33.3%. So here we are going to have 33.3%. P character is 2 over 3 times this, of course, which will give us 66.6%. So percentage P character, 66.6%. The bond angle is 120 degree. The shape is trigonal planar. Is that okay? So how is it like? Based on what we've done before. You have the X orbital down here. The reason why we are showing this to you so that you know that the P orbital are higher in energy than the X orbital. So we have this. So this is X, this is P. Then hybridization took place. Now what are we expecting? We are expecting to form the hybrid orbitals. But where are we going to place them? You see, the hybrid orbitals are still towards P orbital, so they will be a little bit lower than P, but higher than what? X. But they are not towards P like those of sp3 hybrid orbitals, because S carried 33%, P just carried 66%. Unlike the previous one where S carried 25% and P carried 75%. So it will be somewhere almost at the middle, but not at the middle. So you have something like this. Now, 3 hybrid orbitals will be formed simultaneously also. So you have something like this: 1, 2, 3. And here will be what? sp2, sp2, sp2. Now, one of the p orbital is unhybridized. One of the p orbital is what? Unhybridized. And which of them should we say is unhybridized? Let us say this one is unhybridized. So the one that is unhybridized will also be at the same level as the initial atomic orbital. So you see, I'll put this one at this position here to tell you that one of the p orbital is unhybridized. This one that is unhybridized is what will now form pi bonds. So pi bonds are formed from unhybridized atomic orbitals. So in this, for sp2, you see, we said for sp3 we form 4 sigma bond. For sp2, all these ones that are hybridized, they will form sigma bond. So for sp2, my dear student, you are going to form 3 sigma bond and what? 1 pi bond. So wherever you see 3 sigma and then 1 pi bond, know that you are talking about what? sp2 hybridization. Is that okay? sp hybridization. The bond angle is what? 120 degree. Of course, we said that the something will look, the hybridized atomic orbitals, they will look like balloons that are tied at one end. You have something like this, bigger one. So let me just try and sketch I to be. This is one. Drawing is not for me, but definitely that is how it will look like. All right. So we said for sp3, you have 1s hybridizing with what? With 2p. Then 1p is unhybridized, which we kept here. So these one, they are the unhybridized atomic orbital. Then hybridization took place, and then here you have the hybridized, and then you also have one unhybridized atomic orbital. Is that okay? I believe what we have been doing so far is not too complex for any one of you to understand. So we have basically 3 types of what? Hybridization. You should take note of that. Basically 3 types of hybridization. Sorry about that. Basically 3 types. All right. Let's see the next one. SP. Now, my dear student, what is SP hybridization? We are going to look at some of those things we've looked at before. 1. Percentage. What the hell is this? Percentage S character. Percentage P character. The shape, bond angle. All right. So percentage S character, for this one, you just SP. Total 2. X is how many? 1. So it's going to be 1/2 times 100%, which is what? 50%. So here is 50%. If S is 50%, P will also be what? 50%. The shape, it is linear. Bond angle is 180 degree. Why? Because it's angle on a straight line. When you say something is linear, it's on a straight line. So the same thing that we've done before, we'll also come here and do it for this one. So this is the X, these are the 2P, and then hybridization took place. So this is P, P, P. So what we are going to do for SP, you are only using two atomic orbitals, this one and this one. So these two are all hybridized, unhybridized rather. So at the end of the day, my dear student, when hybridization took place, so you have hybridization, the process. What are you going to form? Now, you are going to form hybrid orbitals. Which will be in between, directly in between X and P, 50%. So we can place it as somewhere around here. Two of them. And then you are going to form two hybrid orbitals that are unhybridized, which will be directly the same level with the p orbital. So unhybridized atomic orbital, they will form the same level as the initial atomic orbitals. So at the end of the day, you have something like this. Here will be what? sp, sp, 1, 2. Is that okay? So that this is what you are now going to form. I told you that hybridized atomic orbital gives sigma bond. So here you are going to form two sigma bond. And how many pi? Unhybridized will give pi bond. All these ones, they are unhybridized. Unhybridized. Why these ones here? They are what? Hybridized. So this is going to give us two sigma bonds and two pi bonds. So that's basically how to know the different types of hybridization. Are you getting it now? Exactly. So that is that. Now, you have a question here that says, how many sp3 hybridized carbon atoms are here in this structure? All right. So in order for us to solve a problem like this, firstly, we need to have a problem solving strategy. Now, what's the problem solving strategy? First of all, we have to bring this structure out in such a way that we show all the hydrogens. Is that okay? So we have to show all the explicit hydrogens. 1, problem solving strategy. 2, show explicit hydrogen. That is the first one. Then 2, you should know that if you have 4 sigma bonds, the hybridization is sp3. If you have 3 sigma, 1 pi, the hybridization is sp2. If you have 2 sigma, 2 pi, the hybridization is sp. Is that okay? So let us look at this one critically. If you look at this, bringing out the carbon atoms that are present here, you have this is a carbon, 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 carbon, carbon. Is that okay? Now, in this carbon, I taught you earlier that if you want to add explicit hydrogen, carbon must be what? Tetravalent. Valence rather. That is it. We have 4 valence electrons. So we need to add 3 hydrogens here to make the valence electrons in carbon to be how many? 4. Here, you already have 1 here, 1 here. We need to add how many? 2 valence electron. Here, 1, 2 valence electron. Here you have 1, 2, 3 to make it 4. Here you need to add 1 to make it 4. Here you need to add 1 to make it 4. Here you need to add 1 to make 2 to make it 4. Here you add 2 to make it 4. Now you see that all the bonds you have here around the carbon are all sigma bonds. Is that okay? Now because the bonds around carbons are sigma bonds, you agree with me that these, if you look at this one, are all single bonds rather. This first carbon has single bonds all through. So this is a sigma bond. Sigma, not sigma. All the bonds here are single bonds. Sorry about That somebody's distracting me with their key here. Coming. All right, as I was explaining, you see that all the bonds around here, the 4 bonds are single bond. So it means that this one is what? sp3. So we have 1. All the bonds around this are single bonds too. So it's sp3. So we have 2. Around this carbon 2, the 4 bond 1, 2, 3, 4. Single bond, sp3. This one the same thing, sp3. So number 4. This one the same thing, sp3. So we have number 5. Here is 6. Here is 7. Here is what? 8. They are all sp3. So in this compound, you have 8 sp3 carbons. Is that okay? You have 8 sp3 carbons. Now let's go to the next one. For this particular one, how many sp3 carbons do you have? Now, if you want to bring them, this carbon, 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 carbon. Yes, carbon. Here's what? Carbon. Are you getting it? Almost all the carbons here, even including this one, they are what? sp3 hybridized. Are you getting it? If you put the hydrogens and do it the way I showed you, you see that all of them contain single bonds. So when you see carbons and all the bonds around the carbon atom are single bonds, you also know that that carbon is sp3 hybridized. So here you have 1. Here is what? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Am I counting right? So we have 14 sigma bonds. All right, 14 sigma bonds. 14 sp3 hybridized carbon, not 14 sigma bonds. So sp3 hybridized atoms, 14 of them. Are you getting it? They may ask you to count the sigma bonds. You have to start counting. But that one is, since you are writing CBT, nothing of such will come. All right, so for this particular one, still the same thing. How many sp3 hybridized carbon atoms are here? Now, for this case, still the same thing with what we have done before. So we have something like C, 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 C. All these ones, they are sp3 hybridized carbon because, yeah, if you even put the hydrogen to be only single bonds that will be there. So if we want to count, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 sp3 hybridized carbon atoms. All right, hybridized carbon atom. All right, let's see the next one. This will say how many sp2. Now, whenever we talk about sp2, the first thing your mind should go to is wherever we have a double bond, because we said sp2 usually form pi bond, 1 pi bond and 3 sigma bond. So look at this carbon here. It's a potential sp2. This carbon here is another potential sp2. Now let us count. This is a sigma bond, sigma because it's a single bond. This is a sigma bond because it's a single bond. Say all single bonds are sigma bond. Then these 2 bonds here, one is a pi bond, the other one is what? Sigma. So in total, how many sigma bonds are you having here? 3 sigma, then 1 pi bond. Now when you have 3 sigma, 1 pi bond, what kind of hybridization is that? sp2. So we can say that this carbon atom here, this particular one, is sp2 hybridized. All right, this one, you see the same thing. Look at it very well. This is pi bond here. This is sigma. This is sigma bond, and the tetravalency of carbon is not complete. So I will add 1 hydrogen. This hydrogen here is also a sigma bond. So in total, how many sigma bond? 3 sigma bond, 1 pi bond. 3 sigma bond, 1 pi bond, sp2. So here is another sp2 hybridized carbon atom. So in total now, how many sp2 hybridized carbons are here? 2 sp2 hybridized carbon atom. You have this one. Told you that the first thing you should look out for is double bonds. So here you have double bond is double bond. So here, let me just use this carbon, 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 carbon. Now just note that these three here are sp. If you count it based on what I said, here is pi bond, here is sigma, sigma, sigma. 3 sigma and 1 pi. What kind of hybridization? sp2. Here the same thing. How many sigma? 3 sigma, 1 pi, sp2. Here 3 sigma, 1 pi, sp2. Here 3 sigma, 1 pi, sp2. We are talking about only carbons. So in total 1, 2, 3, 4. 4 sp2 carbons are here. Is that okay? So that is basically that for this case. Now how about this one? How many sp hybridized? Now you might just look at this and say, it's double bond, so it is sp2. You'll be wrong. Now if you look at this structure very well, there's something unique about this particular one. Now look at this. This is a carbon atom. We say wherever we have a double bond, one of the bond is a what? A sigma bond, and the other one is a what? A pi bond. So here also you have sigma bond and pi bond. And I told you that when you have 2 sigma, 2 pi, sorry about that. What kind of hybridization is that? It's sp hybridization. So that's basically how to look at the various types of hybridization and predict them. My system battery is low. See you in the next one. Bye bye.